Hey everyone, welcome to a new episode of Learning How to Code. I'm here with the mechanical engineer. How you doing?
I'm doing great. How about you?
Good. So last time we did a review of everything, and then we also started looking into functions and some of the benefits of functions. So what's one thing about functions that you remember that is an advantage of using them?
If you want to do something many times, then you can just call a function and do that thing many different times as opposed to writing the code multiple times.
Yeah, so reusability of your code, right?
Mhm.
So you can basically modularize everything out, and it makes it a little bit easier to read and a lot easier to follow. And generally, you're going to be writing functions. If you ever do this full time, that's what you're going to be doing.
Mhm.
So we also saw how to call functions, right? You could call it in the top level scope, and you could also have functions that call other functions, right?
Mhm.
So what we're going to go over today is this thing called recursion. Have you heard of that before?
I think it's something to do with repeating or repetition.
Yeah. So basically, the high level idea is that it is a function that can call itself.
Mhm.
So sort of I guess classic example of recursion when you're trying to learn is to compute the factorial of a number. So you know what that is?
Yes. Mhm.
Right. So why don't we start off and we'll create a function. You can call it factorial, and it will take in one parameter, n.
And okay.
So remember, when you define functions, you have to use the def keyword, right?
Yep. Def factorial, and then do I need a space there?
No space.
And
Right. So then when you're dealing with these recursive functions, so if you were on the next line to say add one to a number, don't actually do this, but say you were just to add one to a number and then call factorial of n again,
Mhm.
it would just call itself forever, right?
Mhm.
Until something in your OS or your system or even Python would say, clearly we're in some infinite loop here and we have to stop.
Mhm.
So one of the main things to remember are these things called base cases. So what a base case basically is sort of if the status quo of your recursive function or the system that you're creating is to call itself, what is the case where we want to stop calling ourselves, right?
Mhm.
So in factorial, that would be when our number is equal to 1, because that means we've kind of scaled back, which we'll see in a second, and we're going to hit 1. But for
Mhm.
now, why don't you just type, so basically to compute factorial, right, it is going to be, say we're computing the factorial of 6, it's going to be 6 times 5, 4, 3, 2, 1, right?
Mhm.
So let's see if you can do this. Write the line of code that would return the number times the factorial function at n minus 1.
So I'm trying to think, is there like some sort of factorial, right? So is this what we're looking for?
Yep, but then now we need to make sure that we update
N equals n minus 1.
close. So why don't you remove that line there? And then on line 2, I'll just tell you and then we can talk about it. You're going to
Mhm.
type, so we're going to return n times factorial recursive n minus 1, or factorial in your case, n minus 1.
Oh, I want to return this, right? Is that what you're saying?
Yep, and then you're going to multiply n by that, because that's the definition of a factorial number, right?
Mhm.
Okay, so I would actually put the n times at the front of it because we want to multiply it before we call our function. I'm not
Mhm.
sure if that would matter. I think it does, but regardless. So now what we have is have n like that, right?
Mhm.
And then you're going to multiply 6 times whatever the result of calling this at 5 is,
Mhm.
right?
Yeah.
So basically what I want you to think of is when you call that function, you're going to pop right back up to the top, and it's going to be a new input.
Yeah.
So like I said, though, so say n was 6. If you just ran this the way it was, and say you print the result of it, what would happen to n?
If it was 6? If n was 6, right? And we called factorial of 6?
Yeah.
It would return... Yeah, wouldn't this work? It wouldn't be 6 times 5 times, all the way down to 1?
Well, how does it know when to stop?
Oh, I guess it wouldn't. Would it continue past, 1 into 0 and then the negatives?
Go forever, right?
Yeah. Okay.
So that's why I was saying before we need to have a base case.
Mm-hmm.
Our base case is when we want to no longer call our function, and it's usually kind of like if you think of this as like a tree going down, right?
Mm-hmm.
Where factorial, the first call is at the top, and then this splits into a new call, and so forth.
Mm-hmm.
At some point, we need to cut that chain.
Mm-hmm.
And in our case for factorial, that's going to be when n equals 1. We just want to return 1. We don't want to call anything else. We want it because we're done, right?
Yeah.
So above that line, because remember, we don't want to, anything below return will not execute. So above that, you can just say, when x is 1, and then make sure you have double equal for comparison in conditionals. Okay. And then we just want to return 1 in this case. There you go. So now we will break out of this recursion loop we're in when x finally hits 1, because we don't want to do 0, especially because when it equals 0, that's going to negate all of our progress, right? Mm-hmm. So again, don't worry too much about the code. Like, think about what factorial means. We know that when we hit 1, we want to get out of here. So that return means that your line 4 will not execute because we're done with this function, right?
Yeah. Yep. Mm-hmm.
Now, if x isn't 1, we're going to call this recursion all the way down. So on line 6, why don't we print factorial of, let's just do 4, because that's an easy one to compute in our head.
So we want 4 times 3 times 2, which is 24, times 1, 24.
Yep, and you have a syntax error on line 1. You're missing a semicolon.
Yeah, I wasn't sure if functions, but yeah, they do. They need a semicolon.
Functions, conditionals, loops, anything that you'll tab over, you're going to need a.
Gotcha. Okay, 24.
Yeah. So sweet. That is like the classic example. So the thing to really focus on here is that when you call, as soon as you call that function, you're going to pop right back up to the top. And you can think of n as accumulating as it calls each time, right? So n is 6, so the first time it's going to be 6 times something, right?
Yeah.
And then if you were to write this out, in reality, n is going to be reassigned to the number every time, because if you look on line 4 there, we're actually specifying n by name. So if you were to write out the call to factorial all the way down just in English or in just, math terms, it would end up being n times n minus 1 times n minus 2 times n minus 3 times n minus 4 and so on. Yeah. You see how that works with the recursion there?
Yep. I get it.
Basically, we just, instead of writing this, because you can do this with a while loop or something else, we were able to do this in 3 lines of code, really, and it's going to compute the factorial, and we don't have to write anything else, which is kind of nice. Now, there are some downsides to recursion. We won't get into it too much. I don't think that's going to be in the future when we learn about how functions are called and the call stack and all this. For now, what we're trying. There's one other thing I want to go over about recursion, another example function. And it's kind of the idea of keeping state. So every time that factorial function is called, n is updated, right? But what if we wanted to keep track of an accumulator, right? Or something. If you think about what we're going to write a function to do is to sum things up recursively. So what if we wanted to do something similar where we're summing numbers? Maybe we won't do that. Yeah, so actually we'll do this in another lesson. But the biggest thing I wanted to focus on was that in these recursive functions, there's a lot of pros, but some of the downsides. Can you think of any downside to this aside from the more advanced topics about call stacks and things? Just from your reading code perspective.
I mean, it is a little confusing because you're kind of calling factorial here, but it's you're defining it here. And then also, like if I didn't, do this n equals 1 and then return 1, then like you said, it would run forever. So that could be an issue as well.
Yeah, so sometimes if you kind of get carried away with recursion, it can get really confusing to read.
Mm-hmm.
Obviously, because it's called factorial, like that's going to be pretty easy for us to know what's going on. But the takeaways that I want you to gain from this is that recursion means you're calling a function by itself. And generally, as we get more advanced, it is a really good way if you plan to be doing the same things at multiple steps. It's a good way to break problems down into smaller problems and focus on it at a given time. And then at the very end, if you think it, like I said, that kind of tree diagram we had, then you're just accumulating all the bottom row and you're returning something. So that's why factor is a great one. You can do the same thing with summing. But yeah, so good job.
Sweet. Thank you so much.